Thanks, Jason. I appreciate that. Just to introduce myself, my name is Zach Chadwick. I work here at QA Cafe. I've been here for an awfully long time and have had my hands all over things packet related. And so it's been a while since I've been on a webinar with you all, but I'm happy to be back to talk about our new support for large files in CloudShark Enterprise. So just today, real quick, we're going to go through the problem and some current approaches. We're going to talk about how CloudShark addresses a lot of these challenges. I will be doing a live demo. That is my face. Go over just to summarize everything, get your questions, and get you some answers to your questions, and then hand you some resources before you're on your way. And we will dive right in. So we've all been here before. You're troubleshooting a critical issue. You're going to go pull the PCAP down, and all you need to do is let them know it's not the network, because it's never really the network, and you want to be able to tell them that as soon as possible. And so you start downloading the PCAP, and you realize you're going to be staring at gigabytes of packet data in this time. And this is where these large files and faster networks really start to get us. The PCAP takes forever to transfer down to your laptop. Your analyzer takes a really long time to load. This was the one practicing for this. I started hearing my laptop fans for the first time. This thing sounds like it's going to take off. But once it finally loads, every filter or click, everything turns into another time. You have to wait for the data to load. Your UI slows down, it's unresponsive, and your workflow really is reduced to clicking on something and then going out for coffee while you wait for it to load. And so really, instead of spending time analyzing the problem, you're just fighting with your tools. And the irony of all this is that the captures that matter most are the ones we really can't use effectively. Having all of that data at our fingertips is amazing and gets us to solve our problems faster. However, they're really difficult to work with when they're so large. And never mind sharing this file with colleagues. I'm still waiting for my laptop upgrade for enough RAM, and so I can't even load some of these things. So today, we're going to talk about some existing ways around this problem, and I'm going to show you how CloudShark's new large file support addresses these directly with its web-based PCAP analysis tools. So the first thing you hear, and I think I've even said it to people, is just capture less. Apply a capture filter. Don't get as many packets when you're loading in. And capture filters are not always the answer. There's a few places where they are really good. If you are hyper-focused on one specific exchange, one host, one exchange, if it's like an 802.1x authentication issue or a DHCP problem that you're looking for, a capture filter is perfect in that situation. But if you're looking at broader issues, it's really difficult to know what you need to capture before you capture it. If it's an intermittent issue, you need to make sure you catch it. There's not usually a second chance at a customer site for capturing an event that may or may not have happened. You don't want to get back to your lab and realize, oh, I missed it, I filtered it out. And a lot of the times, just a fire hose is the only thing you have available to you. You're going to be on a span port, you're going to have your tap in line, and it's just a deluge of data. And that's especially true when multiple machines are involved. If you're looking at traffic between a database and a web server or a proxy, it's just a lot of packets that you have to sift through. So what are some ways of dealing with lots of packets? Well, at a high level, there's traffic summaries. And you can look at NetFlow data to get your traffic sort of metadata and information about what's going on in the flows. Dashboards are really good for getting you that high-level summary. But really, we are packet people. We want to be down in the packets. And so those high-level details just don't help us out. They really lose a lot of fidelity where it matters. If we don't need the packets, if one of those higher-level tools solves our problem for us, fantastic. But we're going to assume that we do need to be down there in the trenches with that data. Limiting capture size is another thing that comes up a lot, where you want to snip off the payloads. That's great for making your files smaller, but it doesn't change your packet count. And a lot of times packet count is even more impactful than the file size. And especially if you're troubleshooting any sort of application layer issue, the packet payload data itself is actually going to be important. You don't want to cut it out. So what we're left for with our tools in current workflows is splitting them up. This lets you preserve every single packet. You're not summarizing, you're not splitting them up, you're not losing packets, you're keeping them all together. Your full protocol decodes are available. All your timing information remains intact within those individual splits. And the only drawback you could really say is that you're going to end up with lots and lots of smaller files. Instead of one giant one, you have lots of smaller ones. But we'll talk more about how we can solve that in a moment. So looking at the different approaches of splitting a file, we have outlined three here to sort of dig into today and talk through. One of them is slicing out a time slice of an event. So you know when the event started, you know when it ended, you can snip out just that time range from your PCAP file. Another way is to slice the file into multiple smaller files and doing that by equal duration. So say you want to take 2-minute long chunks across an hour long capture and then compare those with each other or analyze those individually. This is really helpful when you have, more timing information or time related information about the event. The other way to do that is through equal size PCAPs, and maybe the timing doesn't matter so much. You just want them in a nice, smaller, easy to load, easy to navigate, smaller file size, and you can do that on equal file size. And so today, a fantastic tool we have to do that on the command line is edit cap. And so just to show you a few examples of how you would do this right now, edit cap comes with Wireshark. Wireshark is fantastic. It is the best network analyzer out there. It powers everything we do here at CloudShark, and it's a very powerful tool that everybody, I'm sure, is well aware of and uses every day. With edit cap, you can use these -A and B options to say when you want to take a time slice from, when it starts, when it ends. And what's only funky about this is that either needs to be your Unix epoch time, which is, I think, the number of seconds from 1970. It's before my time, or a timestamp field. But you can do that and slice out a PCAP file and then get a smaller, more focused look of what you want to analyze next. When you're chunking up a file by duration, edit cap has a flag -I, which lets you specify a number of seconds to slice up. And then every PCAP file that it creates, and it can be a lot of them, will each cover that time duration. So in this example I have here, we're extracting 120-second timestamps, which is about 2 minutes. And finally, edit cap's last great option for splitting and chunking is the -C option, which lets you do packet count. So this is when the time of day doesn't really matter, or you want to work with other tools in a consistent way. This will again create lots of splits that each have the same number of packets in them. So there's a few challenges here. To start with, this first file you're trying to open could be gigantic, and you might not even be able to look at it to see how it would be a good approach to split. You're going to be splitting blind. You're going to need advanced familiarity with CLI tools to be comfortable in that environment. And to even start on the local disk, you're going to need to copy that file to your laptop to begin. Just that transfer alone could take a long time. And as we saw in our split examples, this can create so many more chunks to manage and organize. They fill up drives, they fill up folders, they litter your desktop. We need a good way to manage those. And then you also need a really good way to find the packet data inside the chunks that is important. And there's tons of advanced scripting that we can do, but not everyone's comfortable reaching that for that first. So CloudShark addresses these challenges when you're dealing with splits from a large file. CloudShark lets you quickly open files of any size without hanging or crashing. It lets you preview data so you can choose the best splitting strategy before you begin. Because it's CloudShark, all your files remain in place on the server. You don't need to copy them down. You can do everything web-based and there's no CLI required. Each chunk is managed and indexed so that you can apply tags, do sharing, use your auto-delete rules to control how long they get left around. And best of all, my favorite part is that you can use deep search across all those chunks to find packets in all the individual files. So a quick recap, if you're not super familiar with CloudShark, if you're new to this, if it's been a while since you've talked with us, I will just give you a quick overview. CloudShark Enterprise, centralized web application server that runs on-prem and stores all your PCAP files on the server for your analysts to use through a web interface. You don't have to download these giant PCAPs. All the data stays secure online. It's behind user authentication. You can share anything with just a URL. You're not transferring files around. And like we've said before, these large files, as files keep getting larger, don't overlook file transfer time. Just pulling down the file can be a strain on your bandwidth, on your machine, on your network. They can stay within CloudShark and be analyzed there. So the CloudShark workflow looks like this. This large PCAP stays on the server. We let you see the data first, preview it quickly with a really short time to first packet. You can then leverage the new split PCAP tools built into CloudShark to create your splits, and then apply deep search across all of them to find the packet you're looking for. So time to first packet, what is that? This is a phrase we've used to describe how quickly a file loads and starts showing packet data to the viewer. And so a lot of times, if you open up a large file, you have to sit and wait for the entire thing to load before you can see even the first packet. And CloudShark has some optimizations around that, so it can display the first 5,000 packets quickly, no matter how big the file is. The rest of the file continues to load in the background, so you do get additional data, but you're not limited on seeing anything before it starts. This is because when it's too big to open, it usually means it's too big to even start. So CloudShark now detects large files and automatically switches to large preview mode. This lets something like a 4 GB file open up in seconds instead of minutes, and you get immediate access to packets. You see our nav chart overview showing you bandwidth spikes and what the general flow of the packet is. And best of all, the whole system remains responsive. No more sad Sharky. So why does this matter? Well, you can start analyzing immediately. You pop it open, you can immediately see a file, what's in it. Was it a good capture? Maybe you grabbed the wrong data. You don't want to wait 15 minutes to download a PCAP of the wrong data. You can look at it right away before you start going into your splitting work. And then seeing that information helps you get an idea of how to split it. And of course, this maintains system responsiveness and resources. No more hanging up the server or pages not responding or UIs crashing. So new in CloudShark, this is our new split PCAP tool. There's no more external tools required to perform this operation. You don't have to download the file, make the splits locally, and then re-upload it. This is a huge time saver built into CloudShark. We've put it in the export menu, and so it's automatically suggested when a large file is detected, but it's also always available for files of any size. And CloudShark has built this tool to do the same split techniques that we just talked about in EditCap. So let's take a look at those. First up is time slice. What's great about this is that it's visual. You see your nav chart, you can drag your sliders back and forth, and you can zero in on a slice of time that the PCAP has traffic for. And so this is really useful when you know what time an incident occurred. You can also specifically avoid or isolate a bandwidth spike, and you can share that specific problem period with another team. You can also trim irrelevant portions off of the trace file if you don't need to preserve those. The next tool in Split PCAP is our chunking into multiple PCAPs. And this can be done like we showed in EditCap by packet count or by interval. This tool is very helpful where it shows you the number of files you're going to end up with before splitting. That can be useful to avoid, having too many small files. And this creates new sessions. And everything in CloudShark is, we call it a capture session. And that is a unique URL on the system that can be shared, have users and groups assigned to it, and protected from auto delete if you want to keep it around. So all of this is helpful when you want to systematically break up a large capture, create consistent segments for review, either for yourself or distributing amongst multiple teams, or if you're doing interval-based comparisons. After splitting, CloudShark brings you to the split list. This shows you all the chunks from the original file. It's a CloudShark index, so it's sortable. You get your bandwidth charts, your tags, your metadata. All of that's there, all your stats and controls. And the best part, like we were saying about before, is that this gives you easy access to deep search. And that deep search is then scoped specifically to your chunks of the larger file that you just had. So deep search is where we're really improving upon that directory full of smaller PCAPs that you end up locally when you're running EditCap. They each load quickly, but how do you find which one you're looking for? You're reduced to searching through all of them one at a time. And this is what deep search was built for. So a quick recap, deep search has been available in CloudShark for a while, but this lets you search in parallel across your entire repository using Wireshark's display filter syntax. There's nothing new to learn, and anything that you can represent as a display filter can be applied across an entire swath of capture files and let you find exactly the one you're looking for quickly. And again, all of this is web-based. And so you don't have to download anything. You don't have to do any CLI ninja skills to get this to work. It all just works through the web interface. And so some examples of things you might search for. You might search for an IP address or some DNS data or even some wireless signaling information if that's this kind of packet that you're dealing with here. And it's fast. So on this system here, we were able to get through 8.7 gigabytes of packets, and it took only 31 seconds to search all of them, every single packet for that field. So it's really this combined workflow of going from a split PCAP into deep search that's key to making this effective. You get small, fast-loading files for detailed analysis, full search capabilities across a complete data set, and no more manual file management or directories full of PCAPs on disk. And now I'm going to make a quick change into my live demo to sort of show you all these things in action. If you give me a second, Jason can entertain you.
I really like, just having seen the slides before, but I really like your talking when you're talking about filters and trying to cut down the amount of traffic ahead of time. The need to be psychic is really, I mean, the key point, right?
Definitely. Yeah, it's if you know what you're looking for ahead of time, you might not need to be looking for it, but yeah, absolutely. All right. Let me pop into here. I have my CloudShark system up and running. It's running locally. Yep, good, still works. Live demos, that really is my face. I want to pop into this 4 GB botnet capture first. This file came from a capture the flag environment someplace else. I forget. If you really want the link, I can share it with you. We can find it. It's publicly available. But it's a great example of a giant 4 GB file that loads fairly instantly into my browser environment. I didn't have to download it first. I didn't have to wait for it to open. And you can see that it's triggered CloudShark's large file preview mode. And this is a limit set by the administrator of the system to say only the first 100,000 packets or so, it's configurable, have been loaded to keep the system responsive. So you're not dragging down your appliance for the rest of your users. You're keeping it quick for everybody. But this lets you go into split PCAP. And from here, we're going to do a time slice because I know that this is botnet traffic and I really don't want to deal with the botnet spike. And so I'm just going to slice the front of this out so I can take a look at it. And I'm going to apply. And in the background, CloudShark is going to perform this slice, extract it to a new file, which is now down from 4 GB down to 175 kilobytes, and let me look at it. And right away, I can pop into any of my analysis tools like protocol hierarchy to see exactly what's going on in this file. And I might look at TCP, see this. And so my analysis can continue while avoiding that giant bandwidth spike of traffic that I didn't really need to look at because I wasn't worried about it. This file is from a desktop capture from myself, actually. And this file is 2.8 gigabytes. It has 2.68 million packets in it. And we want to be able to open this up and click around and see what's going on. And so for our split here, we're going to choose multiple packets. So we're going to split into packets per file. And I'm going to do 75,000 packets per file. It tells me 36 files will be created. I'm going to hit apply. And it's going to go off and start splitting and importing those. This brings us to our new split list within CloudShark. And you'll see that it auto refreshes as it's loading each of the individual splits. All the metadata has been indexed for them. All of the tags from the original capture has been applied. And each of these is an individual session that I may want to share with a different user or different group. Or if your data retention policies have you deleting files after a certain amount of time, there may be some you want to keep for longer. And so I can opt out of those here. So after that loads, one of the things that we heard in this capture file and why we were looking into it was that one of the users was having trouble getting to their development machine. And so right away, I can go to deep search and I can do something because as we know, it's always DNS. I can do DNS query name and we'll say Sharknado. That's the name of my dev server. And I think there were some DNS issues here. So I can search on that. I'm going to submit my deep search. It's going to start querying across the entire packet capture and finding files that match this display filter. And so already I've zeroed down from the 2.8 gigabytes to find 4 matching capture files out of those 2.8 gigabytes. And it only took about 15 seconds to extract them all. And now when I click into them, I'm able to see that the display filter is already applied that I'm looking for. And so I see some queries Things look good there. We're just going to go back and check each of these really quickly. Each of these files loads really quickly. Yep, query response, that's fine. Try this one. And that's a little different. I was noticing a lot of v6 traffic. And then all of a sudden here, I see a v6 destination unreachable. And now it's trying just v4. And also you'll notice for a while here, we weren't seeing any responses, just queries. So that's interesting. I might then flag this. I might go into more info. I might give it a tag. I might say DNS here. I can save that. And I may even go here and share this with a different team on my system to go explore that. And again, sharing all by URL. Everything's done. Whoever I share this with doesn't need to download the file. They don't need to do anything. They just browse to it and they can see everything I have in there. And so that's a good place to start with that one. Go back here, get rid of my deep search. And so if that was the only one that I was interested in, I can actually clean the rest of these up. Just delete them. They're gone. I saved the one with I tagged DNS. We'll clear these out too. And so I'm not copying lots of files around my system. I'm not getting a directory full of disks. I have the one PCAP that I was interested in, and I found it. So related to that same capture, I'm going to do one more split here. And we're going to split this up by duration. And really what we're exploring here is the user saying that it was the network and it went down. And we saw some DNS strangeness. We saw some DNS stop getting responded to. So I'm going to go by multiple PCAPs and by seconds per file. And let's say we're at 120 seconds. It's a 2-hour capture. This would create 60 files. My math is right. And I'm going to let this run through. And so back in the split PCAP view, you can see my previous split from when I did it the other way. All of those files are also available. So I'm going to let this run for a moment as well. And also steal some water. So right away, what's interesting, when we split by duration, all of these PCAP files represent the same amount of time. They all represent 2 minutes of the whole capture. And so what I can really do here is look at, they're all 119-ish seconds. This one must be at the end because it doesn't have any other packets after it. But what I can do is sort by file size. And notice that some of them have 391 megabytes of data, and some of them have only 25 kilobytes of data. And so let's click into this one and just see sort of what's going on. I see some SYNs. I don't see any other responses. I see some retransmissions of those SYNs. So that's interesting. Let me go back and check the other one. I see a lot of neighbor solicitations, a lot of retransmissions for, again, SYNs. So it is really looking like something is not going on right here. And what I can do even is check my protocol conversations. And if I look just at the Ethernet layer, I can see my Ethernet conversations, mostly broadcast myself. Let's look at IP. And I'm really noticing total frames, frames from A to B, frames from B to A is 0. This system where I was getting the capture was not receiving any traffic at all during this time. V6, 0, 0, 0, 0, 0. So this does lead me to, try and explore, was there a bad cable? Did somebody trip over the switch? Did there something get unplugged? Because there really is no more traffic flowing into this server right here. And that lets us find that out of this by comparing equal duration files and noticing how they're all different sizes. So that's a quick demo. I'm going to pop back over to my slides. And should see slides now. And so to give a quick summary of what we've seen, what we've talked about today, share some best practices, and then get into any questions that have come up in the meantime. And I will try to pop over to the Q&A panel as well, just to see if anybody's added anything. which Jason might need to help me with. Oh, found it. Great. Get it. All right. So in that demo, we saw how easy it was to extract by all the different methods, by splitting up a large file into the different methods. You could extract by time slice, split by duration, split by equal packets. Each of those splits keeps complete fidelity and is an individual capture session on your CloudShark system that can be managed and shared just like any other. Tagged, shared, sent to colleagues, pasted into a Slack message, easy stuff. And so that also means sharing settings, profiles, decode as rules, anything that was also associated with that file is also shared along with the session. All of that's preserved. And this is a major improvement for CloudShark. There's no more freezing or hanging. There's no need to download or re-upload. Download the file, split it up, and then re-upload the individual chunks. It preserves the original files on disk. It keeps links to all your previous splits and lets you search across all this data with deep search. And all these capabilities really have a lot of benefits. Those 4 GB files open in seconds instead of minutes or never if it hangs the system. The built-in split tools let you stay in CloudShark, not lose your flow. And you can leverage deep search to find relevant packets out of the individuals. If you're a heavy tag user, all of those come along for the ride and you can continue to use them and add them to organize. And as I mentioned, if you have rules around data retention, it's very easy to prune files that you don't need or partial files that you don't need anymore. You don't need to retain the one single giant file. You can split it up, find the pieces that you're interested in, and clean up the rest for, to reduce exposure. And the key that ties all this together, that for everything within CloudShark, is that the large files remain on the server in CloudShark. They're not transferred down to your laptop. They're not passed around. They're not sent to different people. So when do I use which split tool? Some common scenarios where if you know your incident time, you can extract a time slice. It's very easy for a fast isolation of a problem window. If you have a 2-hour capture and your user says that something happened at, 5 minutes in, it's very easy to slice that out. If you don't know exactly what you're looking for yet, splitting by packet count plus deep search is a great way to systematically explore and review all the different pieces of the file quickly and easily. If you need to share with other teams, that time slice or splitting works. You can send them only the relevant traffic. If it's a proxy issue, you might be able to isolate the packets for the proxy server and send them that chunk. Same for long duration captures. We showed how using splitting by time intervals was able to let us do a comparison between chunks to help us figure out more of what's going on. And they're all manageable. They're all the right size. They're easy to use individually within your tools. And so I'd love to open it up for questions at this point. There is the Q&A control in your Zoom panel that you can use, and you can type them in there, and we can get to those. I'll give it a moment while I get some.
Hey, thanks, Zach. I really appreciate it. There was just a couple, while we're having some questions come in, there were a couple of things that sort of popped into my head while we were looking at that. Like one, I noticed that one of the workflow things that you did now that you're able to split up the capture like that, either using time slices or packet counts, is now use the file size as a clue as part of your workflow. I thought that was really
Yeah,
neat. Like that's not normally a thing, you know?
right. Yeah, and specifically because you're splitting with a defined time interval. Each one of those files was 2 minutes long. And so you can see the packet rates aren't always the same over those 2 minutes, and you can really do that. Now, if you looked at 10 minutes, you might not have that, resolution to see what was changing with that amount of time. But by having smaller chunks, you really can zero in on exactly what time something happened.
Right. And then you mentioned the profile thing, which maybe we haven't touched on in CloudShark in a while, but the fact that the profiles are preserved means that whatever it is that you were doing with this capture in the first place is going to be what you are continuing to do with all of the split up PCAPs, right?
Yeah, exactly. So I wasn't able to demo it today, but you might apply a profile that has different coloring rules, for example, whether it's Wi-Fi specific or DNS specific or some specific troubleshooting thing. Or you're adding columns or removing columns. Decode as rules are a big one. You may be running some servers on non-standard ports. You can have that all in there. And so those all come along with the session when you create a split. And so if you're sharing it with somebody else, or even if you're just going into it next, you have all of those settings preserved across a new file. And when you come back to it, a week from now, because there's more information to dig into, all of that's still there. You didn't lose any of that information.
Right, right. We got one question. Once you've split up a large PCAP, is there something that links the smaller files together so you can work with them later?
Oh, yes, that's a great question. And I did mean to show that. From the split PCAP tool, there's a link that brings you back to all the previous splits in a file, and that really helps organize them. CloudShark maintains a database behind the scenes of all the different capture files and can actually link them together so that it knows where files came from. Great question. Thank you.
We had someone just mentioned the decode as being preserved is also a pretty huge deal.
Mm-hmm. Yep, all of those sorts of settings are built into your profiles. And so the profile remains with the PCAP file and the profile remains with the individual chunks and it's shared along. So the person you share it with just sees the view you were just seeing. Great.
The other thing that I was thinking about that we've been trying to sort of illustrate in CloudShark Enterprise is because the whole intent here is to make this packet capture and analysis as part of a larger process, part of a larger system. Those large file transfers, that cutting that down to just one instead of many, 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 many.
Mm-hmm. The
I was
same
like,
file multiple times. You're sending it to the
yeah,
next person, they're downloading it. Yeah.
I was thinking about that again, and especially because we've talked about this in a couple articles about how it is that you're deploying your packet analysis tools, and now that you're in a situation where you would even consider looking at a 4 GB file, you know, downloading that several times over links, and paying the cloud resource costs of that, or like you said,
Mm-hmm.
crossing country barriers and things like that is pretty
Mm-hmm.
huge.
Yeah, and then just the fact that you now have that file on your local laptop,
Yeah.
which, is probably not the best practice for that. It just takes up space. It could not be something you're allowed to do. So really CloudShark solves all those problems by leaving the files on the server, but letting you do your analysis right through your browser.
Here's one. If I split a large capture and find a TCP stream that spans multiple smaller files, is the way to put them back together so I can use tools like FollowStream.
Yeah, fantastic question. Within our regular CloudShark index, any files that you have, you can also merge back together so that if you did find a deep search across a file, the files that match could then be merged so that you're going to stick them together and then open it as one, which would reassemble your stream.
All right.
Cool. We've put together some resources to talk about this. Everything starts support.qacafe.com/CloudShark. That's a great place to go for all your technical information and user guides on this new feature. We talk about our new split PCAP user guide. There's a deep search overview if you're unfamiliar with deep search or haven't used it to its full potential yet. And also additional support for the sysadmins on large file support and documentation and how best to set that up for your users.
Yeah. Yeah. And Zach kind of hinted at that during the process, but like the maximum number of captures you want when you do quick view is an admin setting. And I think
Mhm.
there's a couple of large file support settings.
Yep, and it's all tuned to how you want to configure your system. If you have a lot of usage or little usage, depending on how many people you have accessing at one time, how it's deployed, if you have multiple instances of CloudShark or not, that's all tunable by your sysadmin and can get started with the documentation there.
Oh,
So this is available if you are an existing customer. This feature and all the capabilities you just saw today and that we talked about are available to download from the QA Cafe Lounge. And if you're not on the 5X series yet, this is a great time to upgrade and take advantage of unlimited instances and users. We now 5.0 introduced, repository-wide deep search. You can search for any file on your system. It's no longer capped or limited. You can spin up as many instances of CloudShark as you'd like. It's a really good time to do your upgrade, so I recommend you check that out. If you're not a customer yet, get in touch. We will be happy to let you run CloudShark and try it out with your own PCAP data, go through some workflows, share with your team, experience what it's like not having to copy the file down to your server to do basic analysis. And if you're still exploring, you can always find out more by visiting qacafe.com/CloudShark.
Great. Well, thanks a lot, Zach. And for those who are always curious, video will be made available later, as well as the slides and a helpful summary of everything we talked about today. So look forward to that.
Okay.
All right, everybody.
Thank you,
Thanks a
everybody.
lot, and we will see you.
All right. Thanks.